Hello and welcome. This is Dan and we are continuing our inverse function series. In this lesson, we're going to go over quadratic functions. So quadratic functions are normally in the form of y equals a times the quantity of x plus p squared plus q. But for this, we'll use the much simpler version of y equals ax squared. And in order to get the inverse, just like we talked about with the linear functions, all you do is you swap the x and y variables, and then you solve for y. So let's try one together. We have f of x equals 6x squared. So we write this out as y equals 6x squared. Now we swap them. So we have x equals 6y squared. That's supposed to be a 2. There we go. And now we solve for a y. So first thing is we divide by the coefficient and we get y squared equals x over 6. Now we need to take the square root of both sides. So we got y equals the square root of x over 6. So this means that our inverse should be the square root of x over 6. So let's take a look and see what this looks like. So in the red, we have our original function, and in the blue, we have our inverse function. But does this look right? I don't know. It doesn't really look like it's one of those things that would pass our function test. Let's do our vertical line test. So as we go down, we see that for the red, we're only touching it once, but for the blue, we just touched it twice. And that'll continue as long as you're doing this. But that means that this is not a function. So what does that mean that we have to do? Well, what we have to do is we have to restrict the domain and the range of our function. So what we do is we restrict the domain of our original function so that it restricts the range of our inverse function. So let's start this over then. So we have f of x equals 6x squared, where x is greater than or equal to 0. So here we start the process all over again. We have y equals 6x squared. We swap them, and then we solve for our y. And so we have y equals the square root of x over 6 for x greater than or equal to 0. So when x is greater than or equal to 0, we can just put a plus sign in front of there. So now our f, or inverse of f of x, is equal to x over 6, or the square root of x over 6. So let's take a look. This now passes our function test. So now we want to take a look at what our domain and range is. So remember, for our f of x, we restricted our domain so that it was x greater than or equal to 0. And if we take a look at our range is also y is greater than or equal to 0. So when we look at our inverse function, we swap them. So our domain becomes x greater than or equal to 0, because we take this and we put that there. And then this one goes here, so we have y is greater than or equal to 0, which was exactly what we had to begin with. But this is what you have to do for determining your domain and range for your inverse functions. So let's do another one. Here we have f of x equals 2x squared, and this time we're looking at x less than or equal to 0. So we have y equals 2x squared. We swap them and get x equals 2y squared. So now we have to divide by the coefficient. We get y squared equals x over 2. So now we take the square root, and we have y equals the square root of x over 2. So you'd think we're done here, but we're not done just yet. So since we are putting a x is less than or negative or less than or equal to 0, what happens is when we do our inverse of f of x, we are going to say this is equal to negative square root of x over 2. And we will see exactly what that looks like. So these are our functions here. And you can see that it is kind of mirrored along our y equals x line, which is exactly what we wanted. So if we think back to what we had in terms of our domain and range, we can see that for our domain, this is going to be x is less than or equal to 0. But our range is y is greater than or equal to 0. So remember, for our inverse function, these swap. So our domain here is x is greater than or equal to 0, and our range is y is less than or equal to 0. And that's your domain and range. So let's do one last one together. So here we have f of x equals negative 3x squared. And we're saying that x is less than or equal to 0. So following our steps, we say y equals minus 3x squared. We swap the x and the y, and then we solve for our y. So we're going to divide by negative 3. So we get y squared equals x over, we're going to put negative 3. So that means when we take our square root, we say y equals the square root of negative x over 3. And since we are using x less than or equal to 0, when we do our function notation, we're going to say it's negative square root of negative x over 3. And so this is what our function becomes, or our inverse function becomes. So when we take a look at our graph, we can see that now, again, we will draw that. You can see that there's still a mirror reflection of each other about the y equals x line. But what about in terms of our domain and range? Well, our domain for our red line, which is our original function, is x is less than or equal to 0, and our y is also less than or equal to 0. And since these just swap for our inverse function, we have x is less than or equal to 0 and y is less than or equal to 0. And that's exactly how you do your inverse functions for quadratics. I hope you guys had fun, and if you have any questions, don't hesitate to ask us using the Ask a Tutor or in the live lessons. And I will catch you guys next time when we go over exponential functions. Bye.